This lesson is going to cover two topics at the same time. The first one, multiple representations of a quadratic, and the second one, finding the vertex of a parabola. So here what I've done is I've drawn figures 0, 1, 2, and 3 for a quadratic situation here. Notice figures 2 and figures 3 I've circled and labeled different parts of these tile patterns. If we look at each one of these tile patterns, figure 0, figure 1, figure 2, figure 3, they all have these two tiles on the right side of the figure. Also, if we look at figure 3, if we get rid of those two tiles, we have a 4 by 4 square. If we look at figure 2, we get rid of those two tiles, we have a 3 by 3 square. If we look at figure 1, we get rid of those two tiles, we have a 2 by 2 square. And if we got rid of those two tiles here, we'd have a 1 by 1 square. So we can see that we have two tiles plus a square. So if we just come up with a general figure x is going to have those two tiles at the end. And it's also going to have a square. The length of that square is x plus 1. And that comes from looking at the lengths of all of these. In figure 3, the length of our square is 4 by 4. In figure 2, it was a 3 by 3. So it was always one more than the figure number, or the figure number plus 1. So if we're looking at figure x, each side is going to be x plus 1. From here, we can make a table. If we count up all the values, or all the tiles that were in each pattern, we can make a table. So figure 0 had 3, figure 1 had 6, figure 2 had 11, and figure 3 had 18. If we look at the difference as we go up in the table, we're going up by 3, by 5, by 7. There's a pattern there. Each time we're increasing by 2 more than we were the last time. So next time we're going to go up by 9, and then 11, and then by 13. So we can fill in our table. Notice we're not going up by the same amount every time. So this isn't going to be a line. This is going to be a parabola. And if we plot all of these points, we get a graph that looks like this. We can also write the equation for our parabola. Since the area of a square is length times base, we can find the area of our parabola, or our tile pattern, by taking the length times base, x plus 1 times x plus 1, and then adding those two tiles that were on the right side of the square. So our area can be represented with that equation. And we can find a few more values to fill in our table too. If we plug in -1 for x, we get 2 for y. If we plug in -2 for x, we get 3 for y, and if we plug in -3 for x, we get 6 for y. So we should be able to go from the tile pattern to the table, and from the tile pattern to the rule, from the table to the rule, from the rule to the table, table to the graph. Okay. Right now, may not be quite ready to go from the rule to the graph yet, but that will come. So after we've graphed our points from the table, we can see that there's this turning point at the bottom, the lowest point on the parabola. That's what's called our vertex. So in this case, the vertex of our parabola is at -1, +1. It's difficult to see where that comes from when we look at our equation, but we're going to take a look at another example here and find out how we can solve that just by looking at the equation. So here's an equation, y equals x squared plus 2x minus 8. So you should be able to make a table for that. Plug in values for x and solve for y. I chose x values going from -4 to +4. For example, -3. -3 squared is 9. 2 times -3 is -6. 9 minus 6 is 3. Minus 8 is -5. So I do that with all those points to find the values for my table. From my table, I can graph this parabola. Notice also that a parabola is symmetric. We could draw a line down the middle of this parabola, and it would be the same on both sides. We could fold it over that line, and we'd have the same thing on both sides. We can see that symmetry in our table as well. -1, -9, on each side, we go to -8, -5, 0. If we kept going in this direction, we'd have 7 and 16. That symmetry is also going to help us find our vertex. We have two x-intercepts for this parabola. One of them is at -4, 0. The other one is at 2, 0. Our vertex is halfway between the x-intercepts. So halfway between means we need to add them up and divide by 2. We need to find the average. So -4 plus 2 is -2, divided by 2 is -1. Well, those are the x-intercepts. That's our x value for our vertex, -1. To find the y value for our vertex, we can either look back at our table, where we had x was -1, and see that y was -9, or we can plug -1 back into our equation. -1 squared plus 2 times -1 minus 8. -1 squared is 1. 2 times -1 is -2. 1 minus 2 is -1. Minus 8 is -9. So our y value is -9. So to find the vertex for a parabola, first make a table, then graph that table, find the x-intercepts, and use those x-intercepts to find the vertex. Find them halfway between the x-intercepts, average the x-intercepts, that gives you your x value, and then use that x value back in the equation to find the y value.